Thank you. Thank you.
Hi everyone. Hi everyone. My name is Praveen Kumar. I have Ansh with me. He'll be presenting you today on OpenCV. So before we get started, tell me how you guys are doing. Please mention the chat window how you all guys are doing. Is everybody okay? Fine. Gavit says fine. What about others? Great. Anushka, we see you being consistent in the sessions. Okay. Ankush, fine. Okay, we are safe. Yeah, that's what we hope for. Okay, so before we start the session, we would also like to know whether you are a college student or you are a working professional. So if you are a college student, you could mention your college name and which year you are into. If you are a professional working into some IT company, then mention the company name and the years of experience. This exercise will help us to understand the audience. So we'll explain the topics accordingly. Can we do that? Yeah, Supriya says definitely. Okay, we have responses coming in. Okay. Okay, we have people from the cybersecurity domain as well. Okay, we have people from the master's degree as well. Could you please unmute? Could you please unmute yourself? Whoever has put himself or herself on unmute. You can unmute yourself whenever you want to ask your doubts or you have any query. Okay, we have people from TCS. So people are from diploma in data science as well. BTech third year UBCE. Great, great to know the audience. So okay, we have a mix of audience. We'll take the session accordingly. The whole motive of the session is to impart the knowledge from the scratch and take it to the advanced level. You can always unmute yourself. You can put down your queries in the comment section, whatever query you have, whatever doubts you get throughout the session. At the end of the session, we'll be sharing you the attendance link as well. So make sure that you are till the end of the session. So you will be able to get the participation certificate. Okay. So people who will be there till the end of the session will only be given the certificates. Okay, we have the professor as well from the Dev College, Sarbjit. Hi, Sarbjit. Okay, so without further ado, I'll hand over the session to the Ansh. Ansh, you can start with the session now.
Okay.
Yeah.
So can you guys hear me? Am I audible? Please type on chat box. Right. Yes. Yes. Okay. Okay. Is my screen visible to you guys? Okay. So hello everyone. Welcome to today's session. We can see we have amazing people with us. So in this session, we are going to see what is OpenCV and basics of OpenCV and image processing. We will see various functions we have in our OpenCV and a lot more. Okay, so we will start with my brief introduction. I am Ansnahar. I am pursuing my BTech from IIIT DM Jabalpur. My major area of interest is deep learning and computer vision. So that is all about me. So moving forward. So today we will see the computer vision library, the famous one, OpenCV. So before starting, I would like to ask you guys, how many of you are familiar with OpenCV or you are a newbie? So type yes if you are familiar with the OpenCV or type no if you are new to this field. Okay. Okay, we can see many yes and many no also. So no issue. I will cover from basics to advanced. So yeah, great. So we will start with the introduction of the OpenCV. So first I will introduce you what is OpenCV. OpenCV is a open source computer vision library. Now I hope you guys are aware what is computer vision. For those who don't know what is computer vision is a field of study in which we deal how can a computer can get a high level intuition from the digital images, videos, how can be able to make the computer understand the images. So it is widely used for a image processing purpose. The library which we are going to talk about, OpenCV. So here are some technical things about OpenCV. OpenCV is written in C and C++. It is very fast and efficient. Basically used for an image processing task, video processing task. So in Python, we have a lot of many libraries. We have Pillow for for image processing. We have Scikit image. We have Matplotlib. But the point is, why we use OpenCV? Do you guys know about it? What's the major advantage of using OpenCV? You can write in a chat box. Okay. I can see no. Okay. Yeah, we do play with the images, I guess, but we have other libraries also. What is special about OpenCV? Can someone guess? Okay. Let me take it. Yeah. We do image detection also using OpenCV. So I will introduce you. OpenCV is we can see. Yeah, open source, it is correct. So OpenCV is a open source library. The other libraries below Scikit image, they are also open source. So the main reason why we use OpenCV is that it is one of the oldest library we have. OpenCV has served developers in a computer vision for a very long time, and it has 2500 plus functions in it that help us to do the image processing task. So that's a major advantages of using the OpenCV. Okay, and it is very fast and it is efficient, and it is written in C++. So that is the technical knowledge. That's why it is fast and efficient. Anyway, anybody is saying something?
I request people to put themselves on mute if you do not have any doubt.
Okay, so it's portable. It can run on any device that can run. Do anyone have any doubt?
No, I guess I Simarjit, I'm putting her on mute. Okay, let's go ahead.
So we will see some applications of the OpenCV. So here in this frame, you can also see we have an image which is basically classifying the faces for us. So this scene is taken from the Jurassic Park. For a human, you can see these are the faces, but how can a computer can learn these things? So we have to make the algorithms to work that. So, okay, moving forward. So we will see real-time applications of the OpenCV. First is very basic face detection. We have image. We put it into a classifier. OpenCV is a hard cascade-based classifier. We will talk about it in our later session. So you put this image into classifier, and the classifier give you a bounding box around your face. So that's cool. Now your model knows what is face and what is not, because and now we have the real-time application of it. This is the camera frame, which we basically use in our day-to-day life. We used to click the camera. We used to click the image through the cameras, and your camera can identify, yeah, this is the image. This is a face of an man or a woman. It can also give you the age. So that's awesome, I guess. So now moving forward, we have face landmarks. So we can also get face landmarks using the OpenCV and MediaPy. So let me tell you one thing. OpenCV is basically used for image processing, and this thing is done by using a classifier. So basically, for building a classifier is the second thing, but first we need to pre-process the image. So OpenCV help us in this task. So I hope you guys are clear about it. So now moving forward, we have face recognition. In face detection, we are only detecting the face, but we can do further improvement, and we can also recognize who's the face belong to. So moving next, we have a cam scanner we used in our daily life. So we can segment out the document using the OpenCV as well. And this is one of the famous object detection algorithm, YOLO, which is basically used for object detection. And basically for image processing task, we prefer to use OpenCV. So many more applications, guys. OpenCV is very vast. It's like a sea. So, and if you are going to build any OpenCV computer vision application, then you have to work on image processing first. So open computer vision combining with image processing and machine learning can have the application in these different fields. Neurology, we can have in mechanical department also the self-driving cars. We can have many more applications, guys. So this is all about the applications of the OpenCV. Now we will see the table of the content today, what we are going to study. So we are going to see how we can read the image, write the image, display it, what are the color spaces in an OpenCV. Yeah, we will go with it. Here it's unsupervised learning, right? Differentiating image colors. We will cover it in our stages. Okay. So image processing. So we will mainly talk about the image processing part in our OpenCV. So we will see how to read the image, how to write it, what are the color spaces, what is resizing, rotation, how we can do it, what's the necessity of doing the resizing, rotation, what is thresholding, image enhancement in our OpenCV, blurring, edge detection, contour detection, bitwise operation in our OpenCV, morphological operation in our OpenCV. And at the end of the session, we will cover two applications of the OpenCV. The first is face detection. The second is road lane detection, which we use in the self-driving cars. So moving forward. So reading, writing, and displaying of the image. So human being has a capability to see the image. So you see this image, the neuron got fired in your brain. So it says, yeah, it's a green capsicum. But how a computer can see the image? I guess everyone knows that the answer. So the answer is array of the pixels. So this is the pic. The computer can see, yes, this is a pic, and we have a array of the pixels corresponding to this pic. The computer doesn't know whether this is a capsicum or this is a banana or anything else, but it knows that this is the image, and we have an array of pixels corresponding to that. So the first stage to building any classifier is to read the image. So how we can read it? So in OpenCV, we have a IMRead function that help us to read the image, and IMSo function to output the image. We will see the implementation part also along with. So since this is a RGB image, it has 3 channels. The one go for R, the second is for B, and third is for green. RGB stand for red, green, and blue. So this part of the image has these pixels, right? So moving forward, so this is how we can implement it. So first we need to import the OpenCV library. How we can do the import? We can import the CV2. Here I import the CV2 as CV. The command we basically use for import the library is CV. I guess I know you guys are aware of that. So this is the image. I specified, you have to specify the path of the image, and this is, and you can use IMSO to show the image. So this is how the image looks like. So the most important thing is the IMRead function in the OpenCV read image in a VGR format. We have other libraries also. Other libraries use RGB format, like Matplotlib use RGB format. So that is the important thing to remember, that IMRead function read image in a VGR format. We can also pass extra flags in an IMRead function in order if you want to if you want to read the image in different format. So we have cv2.imread_color, that is the default, and imread_grayscale, that is if you want to read the image in a grayscale format. So, and this is imread_unchanged. So basically, if your image has some sort of transparency in it, then you need to include one more additional channel that is called alpha channel. So that's where we use the imread_unchanged flag. So this is all about the imread function. Now we move forward to color spaces. So what is color spaces first, and why do we need it? So whenever we are working with the image, we need image in different format, RGB, grayscale, HSV, LAV. We need to do the conversion. For this, we have a handful function in OpenCV, CVT color, that is very helpful to do the color format conversion. So now you guys are thinking why we need a conversion. So let's talk about it. So we will have a quick case study. So in a face detection classifier, which image format you should use? Colored image, grayscale image, both. You can answer in the chat box. B. Okay. No. Okay. Anyone else? Both. Yeah. Okay. Okay. So that is quite obvious that we can use the colored image RGB format also, as well as the grayscale image also. But the thing is, if you want to increase the computational efficiency of your face detection model, if you want to optimize the time complexity, then you will use the grayscale image. I will tell you why. Because in a face detection, we are not bothered about the skin tone. We are just bothered about the edges, the features, and where skin tone doesn't matters, right? If you are detecting an eye, if you are detecting lips, then do you think the color of the skin matters? Yes or no? Type in a chat box. No, yeah, that's why our thinking comes in a play. We can use the grayscale image also, we can use the colored image also, but what's the we need to think about it. So in order to optimize our solution, so we will use grayscale image. Yes, only features matter, that's the thing. So but in our face recognition task, in which we are going to detect about the person's name also, then what do you think, what type of image we will use? Options are same, A, B, and C. Now we are talking about the face recognition, in which we also want to identify the person, whether he is Ansnahar or he is Perveen. So I can see A. Yeah, that's where the color matters. So that's the need of color spaces. We need to do the conversion. And guys, please be interactive in a session, because that's the way we can make this session more interesting. Okay, I can see everyone got it. Somebody is typing grayscale. No, if you use the grayscale, suppose I am a person, right? You are identifying me. The classifier is identifying me, but there can be another variant of me that is black. So if you use the grayscale image, then the both variant will be classified as one uns, but they can be a different person also. So color matters. So now I hope, Sujay, you are clear. Yeah. Moving forward, how we can do the color conversion in our OpenCV. So the function is very handy, CVT color. We need to input the image. In this, we have to give in two parameters. First is image, the image which we in which we perform the operation, and second the flag. We have various flags, just like for VGR to gray, we have color underscore VGR to gray, and for VGR to RGB, we have color underscore VGR to RGB. We have a lot more. We can do a vice versa also. So this is the image. And one more thing, guys, everything is interrelated in this PPT. So be focused in a complete session. So here you can see we have an image. First, I use the ImRead function. I have already talked about it. So I specified the path. I read the image. Now I'm converted to a gray. cv.cvt color img. I give the image which I have read it, and I give the flag also. And here I use the imWrite function to save the image in my working directory, and imso function to basically output the image. Here I have converted it to a different format. I've converted to a HSV format, RGB format. We will see it. This is VGR format. This is our input image. We convert it into a grayscale image. This is how a grayscale image looks like. This is a HSV image. This is a VGR to RGB image. Here you can see the red and the blue position interchanged. Here you can see this is blue and this is reddish, but here you can see this is reddish and this is blue. So that's why. So ma'am, one more question. Can you do you guys know what is SSB format? Yes or no in a chat box, guys. Please be interactive. Can you guess it by seeing the image? Yeah, it's use saturation value. But what that means? What type of intuition you are getting from this image? I'm just asking you this. Light brightness? No, that's for left. Colored, not violet color. It's different color which we are going to use. Here you can see. So this is the wait a second. So this is the image. Now human can see this is reddish, here this is blue, here this is green. But how a computer can see it? We need something na to computer dekh paye. So we will use the HSB format. Here the computer can easily visualize that, yeah, this is the green portion, and this is the red portion here, and this is the blue portion here. So this image is basically how a human perceives thing in their brain. So that is it is telling about the all color variants. The green one, someone, who is this? Okay guys, please do not use the annotate function because it will disturb me in my presentation. So now I hope you guys are clear about the HSV format. Moving forward, we have color channels. We can also split the image in their respective channels. For this, we will use a split function. A split function will help you to split the RGB matrix. So it will, if you use the split function, it will return you the R, the corresponding R, the corresponding green, the corresponding blue matrix. Then we will use the merge function, so that if you get the blue matrix, then you will merge it with 0 and 0. So this is blue, this is green, so green is 0 all, and this is red, so red is 0. So we will only see the blue here. So this is the way we can split the color channels also. So this is an input image, we can split into a blue channel also, green channel, and this is the red channel. So if you superimpose all the three images, you will get this image. Okay, now moving forward, resizing, rotation, translation. So I hope you guys are aware about their definition, because it's just a very basic terms. Yes, yes. I'm very happy, guys. You are very interactive in a session. It really motivates me. So, okay, moving forward, resizing, rotation, and translation. So these are all the basic steps we perform during the image processing. No, first we will cover it from the basic scratch. So why we need resizing, rotation, and translation? These are the main thing. You know, resizing is to do resize of the image. You have a big image, you just resize it to a in different image size. So can you guys tell me what's the use of resize? Why do we use it in machine learning? In a chat box, please type in a chat box, guys, if you know why we use resizing, although it is visible on our screen. Okay, cool. We will see it. So guys, whenever you are building a computer vision model, okay, reduce computational cost, yeah, that's correct. So I will explain it. So whenever you are working with a computer vision models, you need input in a fixed size. You can I can see some more responses. Same size input, output, reduce cost. Wait a second, Anushka. Same size input and output and reduce cost. Okay. I think you are in little confusion. So we will see it. So whenever you are working with a computer vision model, you need image. You cannot fed a different image sizes. So suppose you gathered some data from the internet for your computer vision model. The images are of size, some are in HD, some are in 1028, some are into 400 into 400 size. So you cannot fed the variable size inputs into your model. You have to make sure that all the images are of the same size, then only you can proceed further, then only you can fed these images in your classifier. So that's the need of the resizes function. So what we basically do, whenever we are working on any model, we basically resize it. The data set which we have, we basically resize it to a something that we want. So we can if we have multiple images like 1024 dimension, 400 to 400 dimensions, so we will resize it to a fixed size, so that we can feed this thing in our model. The second thing is to reduce am I audible? Am I audible, guys? Okay, cool. Okay. So the second advantages of resizing is to reduce the computational cost. Suppose you are working, we will take that first example. Suppose you are working on a face detection model, and you have different images, 1024, 1024, 400 into 400, 500 into 500. So do you so my question to you guys is, so what is the dimension you will prefer for an image process, for a face detection task? Are you guys aware of it? Can you take a guess? 400 into 400, 200 into 200, or something else which you have? Yeah, the dimension of the image, I'm asking. 124 into 124 into 3. Yeah, now I will take it. I will now. Okay. So now we can take, there's no any hard and fast tool to know what size works with your model. What you can do, you resize the function, you resize your image, and you see by your eyes, you observe it, and then you, if you can see the image, that you can, yes, you in this image you can figure out, yes, we can classify a face here, then obviously your machine learning, the computer vision model can also perform the same task, because you guys are aware of that, that computer, the CNN model works as per your brain, just like your brain. So that's the intuition you can got. Basically we prefer to use 200 into 200 for a face detection, but we can also increase it or decrease it depending on our need. If we are using a high dimension image, we have a greater matrix, and that's increase your computational cost. So we need to do a resizing too. So in a resizing function, we will see, we will have this this resize function. This is very simple. We have to give img, the image, the dimension which you want, and the interpolation. Now we will see, guys, what is interpolation. So do you guys know what is interpolation? Just yes or no. I'm not asking the definition. No. Okay, guys. So let me tell you something. Okay. So suppose you have this image, okay, and this image corresponding to this matrix. So we have value here, row and the column. Now you want, now you resize the image. So for resizing, you have to add some more pixels here, right? So suppose this is the bigger matrix you have. Now you have to assign some pixels here. If you are increasing the size, so how you would assign the pixels? So that is called as an interpolation. Basically in a DSP, we have two things: decimation and interpolation. Decimation is basically downsampling filter, and interpolation is basically upsampling. So basically what I mean by downsampling is, suppose you are decreasing the size of the image, so you need to drop some pixels. So how will you do that? So that's a so that is one of the thing. And how will you increase the size? So that is called interpolation. So in OpenCV, we have only given interpolation name. So we have different kind of interpolation to do the task for you: nearest interpolation, linear interpolation, area interpolation, cubic interpolation, and the Langeos. So all these interpolation have different advantages. So first I would like to tell, what does a nearest interpolation do? Suppose this is a matrix. Okay, so suppose this is your matrix and this is the value 5. Now you increase your matrix size, then you need to specify interpolate a new pixel. So what a nearest interpolation do, it will basically take the pixel from your nearest neighbor. So okay, so what I'm saying, so you can take this, you need to interpolate this pixel using your nearest neighbor. So that is called nearest interpolation. You can use a linear interpolation also. So these are all the basic advantages of using different type of interpolation. The nearest interpolation is very fast but not that efficient, because what you are doing, you are just interpolate by using the nearest pixel, and inter area is based on area interpolation. So basically it take wait a second. So it take that area and corresponding to it, it will interpolate the new pixel. So what's the major advantage of using the near? So we basically use area interpolation to shrink the image. That is for your information that you need to remember. And the cubic and the linear is for when zooming is required. The cubic is much better because in this we are going to use a 4 into 4 pixel neighborhood. So it will take a 4 pixels here, and then it will take the average and interpolate accordingly, and then in okay. And in a linear interpolation, you will use a 2x2 filter, 2x2 kernel. Sorry for the disturbance, guys. So does interpolation same as zooming? No, interpolation is a method to interpolate new pixels, because if you are zooming, then you need to add some more pixels, right? In your image. So how can you do that? You will use an interpolation method. So that is the thing. Do you guys have any doubt about interpolation? Ask me right now, because I am free to take any doubt. You can write your doubt in a chat box. But this is just a overview of the interpolation and also the working. So I guess you don't have any doubt. So this is the image. In my initial image, I resizes into a 1500 into 1500 dimension. Okay. Clear. Okay. So I use the inter_cubic method. So this is how the image looks like after resizing. The image loses its quality also while we do the enlarging. So just remember that area interpolation is used to shrink the image, and cubic interpolation and linear interpolation is used for zooming purpose, and cubic is more efficient, and nearest interpolation can be used for anything, because it's just taking the nearest pixels, and this is very fast because we are just doing the nearest we are just taking your nearest neighbor, and but not that efficient. Okay. So moving forward to a rotation and translation. So just give me a one word. Why do we use rotation and translation? What's the need of rotation and translation? Guys, you can type in a chat box when data is less. Yes, yes. Yeah, that is the correct point. So suppose you are building an model, but you have only 100 images. So now what you want? Yeah, 100 images is not sufficient, because deep learning models are very data hungry. They need a tons of data to understand the features, to understand the image. So that's why a rotation comes in a play and translation comes in a play. Both are the famous basic image augmentation technique, and one of the most used data augmentation techniques as well. So we will see how we can do the rotation translation. So for rotation, we will use this matrix. this is for the scaling of the pixels, this is for the translation of the pixels, and this is for the rotation of the pixels. So every look at here. So now you have a matrix of the image in which you have different pixels. So this pixels x, you take it here, and you will do the you will give the theta in your model. This is in a polar coordinate, and you will get your new pixel. So new pixel corresponding to that rotated image. So that's the simple mathematics behind it. We use a little calculus here. So this is how a rotation matrix look like. Alpha is scale dot cos theta, beta is equal to scale dot sin theta. So it's just a mathematic thing. Okay, so we will see how we can implement it. So here you can see we define a function rotation in which we specified the image, we specified by how much angle we have to rotate and through what point we have to rotate it. So basically img.shape gives you the dimension of your current image. So if suppose this image is 500 into 500, then you will get height 500 and width 500. So you need two things here. First is rotation matrix 2D, that is this, which you can which you do not have to worry about. OpenCV as a function to make sure that you get the rotation matrix. And and the wrap affine function. What does wrap affine function does? It basically convert your pixels using the rotation matrix function to that to the pixels corresponding to that image. So this is how a rotation function look like. So this is an image I have rotated using the 45-degree angle. I didn't give any rotation point. So it is basically taking the center. Yeah, you can see how you can. So suppose this is 400 and this is 400. The center coordinate will be 200 and 200. So here I specified if you are not giving any rotation point, then it will take as a center. So how you can hard code it? Height divided by 2, width divided by 2. So this is all about the rotation function. And similarly, we have a translation matrix. So translation function. So in translation function, we have a translation matrix, and same thing we will do here. We create the matrix using np dot using this function, using NumPy, the library. I hope you guys are aware of the NumPy as well, and the dimension you will give, and use our wrap affine function. So this is how a translation looks like. So we will share this OLAP file also at the end of the session, so you can check more things from there. So moving forward. Okay, now we have covered the basics of the OpenCV, right? Now we will have a quick question answer session. After this, we will cover advanced function in OpenCV as well. So my first question: by default, the OpenCV IMRead function interprets the image in which format? So I can see, sir, as we gave the value for rotation, translation, can we get same for resizing? Yeah, of course. You have to give the dimension for resizing. If you don't give the dimension, then how the computer will know what size you want? I mean, your own value to resize. So you mean so you basically yeah, you can do that also. I got your point. So you are just asking, can we build a resize function using Scratch? Am I right? Who is this? Yes, Anusa _it. Yeah, you can do it, but I will not prefer it to use, because that is based off time as well. So if you have a function, then you will basically going to use that, because pre-processing stage is the first. Then we have to also build a classifier. We have to do hyperparameter optimization also. So these things takes a lot of time. So what's the point if you are building a resizing function from scratch? So okay, I can see so first answer is VGR. I can see. Yeah, of course. That is correct. For the second, which is the fastest interpolation method? Can I have the answers? I pointed also, guys, to remember. Sujit Reddy is saying linear interpolation. Viswajit, cubic. Sujoy, nearest. Any more responses, guys? Okay, Sujoy, you are definitely correct. As the name says, it is a nearest interpolation. In nearest interpolation, what we are going to do, we are just taking the nearest neighbor. But in linear interpolation, we are using the 2 by 2 window, and whereas in cubic we are using the 4 by 4 window, and then we are taking the average. So obviously, the nearest will be the fastest and has a less time complexity. So are you guys okay about this? Do you have any doubt? Okay, so okay. I hope you got it. So what are some basic image augmentation techniques? So first rotation, second translation, third cropping, fourth flipping. Can we have answer? Yeah, 1 and 2. All. Okay. Can you repeat? Yeah. What are some basic image augmentation techniques that we apply in our data set if you want to increase the number of the images in your data set? Manpreet, are you clear about the question? Yeah, I can see many people are saying 1 and 2, and some are saying all. So, the guys, the answer is all. So, just use your thinking capability. Although I only said that rotation and translation is used for augmentation, they are basics. But apart from this, we can have many more augmentation technique. We also use cropping. We also use flipping in our augmentation techniques also. And these operation we can also perform using OpenCV. The thing I didn't cover this because we have a lot more content to cover, and these are just very basic. Cropping, you just need to define the dimension and it will get cropped, and flipping is also very easy. So we will include cropping and flipping function in our CoLab file because that is very easy. Now I hope you guys are clear about it, that rotation, translation, cropping, flipping, every techniques used for image augmentation. Apart from this, we can have vast more augmentation techniques. So we are not going to cover in this session that thing. So moving forward, now we will see some advanced function in an OpenCV. What we have. This is the second part of our session. So first we will cover what is thresholding in OpenCV. So I know this is some kind of new word for you, for many of you. So thresholding is a technique of assignment of the pixels. So it is the technique used for us segmentation purpose. So this is okay. So this is the image. Here you can see this is a green background, and the person is in air. This is called as foreground, and the green thing is called as a background. So for chroma keying is one of the application of it. So whenever we need to segment this out, right? Because if you are doing some kind of animation, if you are building, making some movies, so you need to segment out the foreground. How can you do that? So here thresholding works. So what you do with thresholding, I will cover it in a later portion. So you basically segment the foreground, and then you can put it on other images also. So you can see this thing. This is a map. You can see this is a water, and this is the land. Okay, so now you wanted to segment the water from the land, because in this image it's not very clear. So what you can do, you can use the image thresholding and you can segment the water out. Here you can see we have segmented the water out from the image. So that's the application of it. So how we are going to do this, we will see. The important thing is thresholding can only be applied on a grayscale images. So that's the point to remember, guys. So types of thresholding we have simple thresholding, we have adaptive thresholding, we have Ostus binarization. So we will cover both every thresholding. Okay. So what is simple thresholding? So basically we will see using an example. So suppose you wanted to segment out this foreground. How you can do this? Suppose what I do, you know that for a grayscale image, the minimum value is 0 and the maximum value is 255. 255 corresponding to a brightest pixel and 0 corresponding to a black pixel. So you need to segment this out. How will you do it? So what you will do, if you can, what I can say, if you can, okay, if you can make all the pixels 255 in this region, all the pixels to 255 value, 255 by 255 I mean the brightest pixel. The brightest pixels are white and the darkest will be a black. So if you can convert this into all white pixels, just like in this case. So and the background, why 0 0 0 0? So 0 and you fill it 0. So you can segment this image from the background. So basically what we do in a simple thresholding, we give a threshold. So let's say you give a threshold of 125 and you know this and you know that this is this value is 135. Okay, this here the value is 135. Okay, I'm not able to write it on a window, and this value is 100. So what a simple thresholding will do, it will check all the pixels. So if the pixels is greater than 255, it will convert it to a 255, and if it is less, it will convert into a 0. So obviously you can see the background is doesn't have a greater contrast, means they will have a less pixels value, and you have to figure one threshold, and after that you can apply thresholding, and all the pixels under this area, the brighter region will get brighter and the darker region will get darkest, will be darkest. So this is how it works. We need to specify. So we have a function for it, cv2.threshold. We need to give 4 parameters: grayscale image, second the threshold value, and third the maximum value you will assign after your pixels is greater than the threshold value, and fourth the type of simple thresholding. So we have different type of simple thresholding as well. So these are all working with the same principle. So what we have in a binary thrashing is, if the pixel intensity is greater than the set threshold, pixel value set to 255, else to 0. Okay, I think we have some doubt. Okay. Do we have some doubt? Okay, I guess no. If you have any doubt, feel free to ask. And thrash underscore binary underscore inverted is just a inverted case. So if the pixel is greater than the threshold, you will assign it to a 0, and else you will assign it to a 255. Thrash underscore truncated. So if the pixel intensity is greater than the threshold, it is truncated to a threshold, and all the other pixels remain same. Thrash to 0, pixel intensity is set to 0 for all the pixel intensity less than the threshold value. So and this is just the inverted case of it. So we will see by the example. So here you can implement it. So here I have used all the 4 techniques. cv.threshold, I give the image, I take the threshold 120. We have to give this threshold. We have to check the image by giving different threshold. We usually start with 100, and then you can increase. We can 120, so that you can get a better result. So your foreground is way more separated. If you increase the higher threshold or lower threshold, you have to check it yourself. So this is the input image. This is the binary thrashing. This is the inverted binary thrashing. This is truncated thrashing. This is thrashing to 0. This is inversion of thrashing to 0. So here you can see the image is not properly segmented, guys. So we need furthermore techniques so that we can get it more segmented. We will cover it in our later portion. Okay. Now moving back to an adaptive thresholding. So what a simple thresholding is doing, it basically using a global threshold, but here what we are using, we are dividing the image in different. Yes, do we have doubt? Okay, cool. So if you are wait a second. So here what we are going to do, we are basically going to do the threshold by dividing this image into a different portion. So this image, so we have divided into a different portion, and then as per the average value of these pixels, we will automatically get a threshold. Here we do not need to give the threshold; it will automatically get calculated, and we will apply the thresholding. Simarjeet, do you have any doubt?
We will request you guys to put yourself on mute if you do not have any doubt. Simarjeet, we have been seeing you a lot. There has been a noise coming from your side, so we may have to exit you from this session if this keeps on happening. So Ansh, you can mute all the participants. Okay, if there is a news coming from their side.
Okay.
If they have any doubt, they can unmute themselves.
Okay.
Just go ahead.
So for adaptive thresholding, we have this function adaptive under threshold. So apart from the thing which we have, apart from the parameter which we have used in a simple thresholding, we have to give two more parameters. So first is the area size which you are going to use to suppose you can use this area, you can also use this area. So that is one of the parameter you have to give, and the method you will use. So we have two methods here, adaptive methods, adaptive underscore thresh underscore mean. So it will basically take the mean of all the neighborhood area, just like this, the area, I will take the mean. So that will be my threshold. Then it will automatically do the thresholding. Okay. So and the other is thresh underscore Gaussian underscore C. So it is basically take the neighborhood values which are from the Gaussian distribution. So we will also specify a constant C which will be subtracted from these value in order to provide some human thing in what you can say, in a threshold, because the algorithm calculated the threshold automatically. So this is the way so this is a way where we can implement our adaptive thresholding. So you specify the image, you give the maximum value which is 255, and you are not giving a threshold here, and you give the method, and this is how the results look like. This is the adaptive mean thresholding, and this is Gaussian thresholding. Here you can see the result is burst as compared to global thresholding. In global thresholding, we can see that we segment the cat images so far, but here it get messed up. So sometimes it worked, sometimes it's not. It depends upon the lighting condition in a image. So here you can see this is the original image I have, I have implemented a global thresholding using a threshold of 127. I get this result. This is this completely ruins my image. Now I use the adaptive mean thresholding, and this is the result I got, and adaptive Gaussian thresholding, and by this I got this result. So in some cases, adaptive thresholding works. In some cases, simple thresholding works. You have to check it yourself. So now we will cover the third technique, Ostu's binarization. So for this, we have to cover the histogram. So are you guys know what? Do you guys know what is histogram? Comment yes or no. I will not ask the definition, but just yes and no. Yes, yes. Don't know. Okay, okay, okay. So histogram is a representation of distribution of the data. Suppose this is your matrix, and you know this is your image, which is and the corresponding matrix is there for this for the image. And now here you have a values, different pixels values. So what a histogram do? It represents the relative frequency of occurrence of various pixels in an image. So you can see zero, the 0 pixels appear twice. So yeah, you can see this is the 0 and it appears twice. One pixel appear only one time. 2 pixels, the pixel with a value 2 appear 2 times. So this is basically a histogram. Okay, I can see no number of time that a particular event is occurring. Yeah, that's correct. But yeah, that's correct. But in our image, number of time a particular pixels is occurring. So that is more correct in terms of image. So moving forward. So how can we plot the histogram? So first we need to read the image. We have to here I plotted a grayscale histogram. Grayscale has one channel, so here you can see only one plot, and here you can see three lines corresponding. So this is the function which we have to calc and hist to get the histogram. Basically, this is the color code, and this is 0. If you are using 3 plots, so you will give 3i. Just like in this case, I use the loop and bin size, and the so this is the bin size. Maximum bin size can be 256 because we are using the grayscale image or RGB image. We have a value from 0 to 255, and this is the range 0 to 256. This corresponding to this range. Okay. So that is all about the histogram. We will see how an Ostu binarization work. So in Ostu binarization, the algorithm calculated the threshold using the histogram. In our adaptive thresholding, we are calculating the threshold automatically by the area. But here we are not using any area. Here we are using the image histogram. We will see how we do it. So suppose this is an image. So corresponding to this image, we have this histogram. Okay. So now suppose. Okay. Now suppose we have to segment the foreground and the background. So what we can do, let's say 2 is the value which is the best value. Okay. So if you apply that threshold of 2, then you will get your foreground separated. So what this do? So if 2 is the threshold you will choose, so it will divide it 2 cases. So the class 1 corresponding to your foreground, or class 2 corresponding to your, like class 1 is for background and class 2 is for your foreground. So basically what it will do, it will try to increase the within class variance, and it will try to increase the what you can say, different class variance. So basically what we are trying to do, we are calculating it the variance of it. We are calculating the variance of it. We are trying to this is how we calculate it, and we try to maximize it. Okay. So if 2 is your value, then within class variance value will be a minimum, and between class variance value will be a maximum. So we will take different value 3. So we will calculate the within class variance and between class variance, and if it is minimum, then that will be our threshold. And so this is how the histogram works. So basically we don't, this is all about the mathematics portion. For the implementation part, we only have a simple single word implementation. So what you do, you implement cb.threshold, you give the image, you give, okay, we will see. Picture value, and you have to give the method. Here you have the method which you are using for simple thresholding, and and along with a flag which will give the computer helps to know that you are using a Ssb binarization. So this is how it is done. And you can see this is the original image. We apply a global threshold. This the image looks like, and this is the Ssb binarization. So here you can see that Ssb binarization image is far better as compared to this image, because here you can see there's black here. The image is not segmented properly, but you can see there's a white, and here you can see the face of the cat also. So it works better. And here we do not need to bother about giving the threshold. It is automatically calculated using the histogram. So that is all about the Ssb binarization. Okay. Do we have any doubt regarding that? Type yes if you have any doubt, or no if you are okay. Okay, I can see you guys are very much active guys. So Joy and Sarat, so Joy and Santana, Lakshmi, Sarabjit also is very active. Yeah, I can see you guys are listening to me. Anusha, Sirisha. Okay guys, now we move to an image enhancement techniques. So if you have an image with a less contrast, like this image, and you wanted to increase your contrast, you go on your editor in your mobile, you increase the contrast, and along with this you have one more function, autofix. So if you put the autofix function, then it will get your image automatically fixed. Yeah. Sir, for us to do, we have to convert to a grayscale? Yeah, for thresholding, you have to convert it to a grayscale. Okay. Okay. So we have our autofix feature, so which we can implement in our OpenCV as well. OpenCV has quite a lot of applications in our real world. So what basically it does, it's a histogram equalization. It will equalize your histogram. So this is the image histogram of a image which have a less contrast, and this is the image which have a high contrast. So you guys need to remember this. If you have a narrow region in between your image histogram only, and you are not having something in right and left, then it will corresponding to a low contrast image. And if your histogram is byte separated, then this will be a high contrast image. So this is what histogram equalization do. Basically, this is the histogram of this image. You can see it has a narrow band here. Here you can see it do not cover all the value from 0 to 250, 255. So what you will apply the histogram, and this is after you will get. So after applying your simple histogram equalization using equalize hist function, so this will be the histogram which you will get, and corresponding to this you will get this image. So here you can see this is how we implement it. Guys, see, everything is connected. We have read the image using IMRead. We covered it. We will use IMSO to show the image. We covered it. We will convert the image in a grayscale. We also covered it, and then we will equalize the histogram by using cv.equalize_hist, and we will output the image, and this is the image looks like using we also say it as a global equalization. Okay, now moving back, we have a clay. This technique is very famous for histogram equalization. This is the adaptive histogram equalization, in which we are basically dividing the image in different window. So here we are basically using a tile size of 8 by 8 by default. So you divide this image by using 8 by 8 tiles, and then you will calculate the histogram for this corresponding thing. The function will calculate, you don't have to do this. So it will calculate the histogram and will equalize it accordingly. So this is basically an adaptive thing. So the result looks far better than the global equalization, you can see, because since it's a adaptive, the time complexity of it will be greater as compared to global histogram, but it will give you a better result. And the thing is, it can be applied on grayscale as well as color scale, color images. So that's the thing. Sir, can we use histogram on medical? Yes, that's the application of it. We use histogram in a medical image. We use the clay techniques in a medical image too. Suppose you are working on an X-ray. Have you guys ever heard of the thing that pneumonia detection using deep learning models using the X-ray of the person? So here sometimes we do not have a good images, so we do need to increase the contrast. We do need to do the image enhancement. So how we do it? We use the image enhancement technique. Along with it, we also use the Ostus binarization and thresholding techniques, because we wanted to segment. Suppose you have a X-ray of your the lower part, and you wanted to segment your lungs because you are working on a pneumonia detection. So thresholding will work there. So guys, computer vision has a vast application. Okay, and we can have a computer vision application in every field. Okay, moving further. Okay, we have a quick question. So what we have covered? We have covered the image enhancement and the thresholding. So which of the following techniques are based on image histogram? Okay, guys, answer me. I am seeing the chat box. 2. Okay, guys, take your time. I can't see the right answer yet. There can be a multiple answer, guys. Think about it. Yes, it's first and second. It's the correct answer. Someone is saying 3, 4, where we are using the histogram and adaptive. In adaptive thresholding, we are using the area, and in simple thresholding, we are giving the threshold by ourselves. So yeah, guys, you got it. First and second are the correct answer. Okay, so I hope you are clear. Yes, first and second are the correct answers. Okay, moving further. So now we have some interesting topics: image blurring, smoothening. So you guys are aware of what is image blurring. Image blurring refers to making the image less clear or distinct. It is done by convolving an image with a low pass filters. So what are the advantages of the blurring? Blurring helps us to remove the amount of high frequency content in an image. It is generally used before thresholding and edge detection. So, and blurring helps us by reducing the detail in an image so that we can find the object that we are interested in. By blurring, low intensity edges are removed. It helps in a smoothing of the image. We will see it through examples. So what type of blurring we have? We have 4 types of blurring: average blurring, Gaussian blurring, median, bilateral. Everyone has its own advantages. We will see. So in average blur, what we are going to do, we are using an average filter. So this is how an average kernel looks like, normalized box kernel 2x2. So how can you implement the average blur? So there's a simple function, cv.blur. You will get the image and you will give the kernel size. Here I get the kernel size of 3x3, and this is how your result look like after doing the average blur. So what we are basically doing, suppose you wanted to reassign this pixel because you wanted to blur it. So what you are doing in the simple average blurring, that you take the kernel size. Suppose you are taking the kernel size of 2 into 2, so 4 into 4. So here we have 4 pixels. So these are the 4 values in a matrix we have. So what we will do, we will take the average of all and replace the first one by the average of all the 4. We will do it in our next iteration. This is the 4. So what we will do, we will replace this using the average of all the 4 pixels. So this is how the image will be get blurred. Okay. So this is if you increase the kernel size, the blurring will be more, and if you don't use, it will be less. So yeah, you can see the kernel size here we use is 3x3, and here we use is 6x6. So it's very easy to apply a average blurring method. It's just a one word function. Now Gaussian blurring, we have advantages of Gaussian blurring. Gaussian kernel is in this, a Gaussian kernel is used. It is highly effective to remove Gaussian noise in an image. Guys, Gaussian noise is the noise which can generate while we do resizing. So in our first case, we do the resizing of the image. So you can see that we get a lot of noise. So we can use the Gaussian blurring to remove that noise. So that's why we generally used in a pre-processing stage in our machine learning or deep learning model. So if you will see any model of someone who has experience in a deep learning, so basically they use the Gaussian blurring before in their pre-processing stage, so to get rid of the Gaussian noise. Okay, I can see this one. Sir, why we have to blur our image before denoising? Basically, it's the way to denoise the image. Vivo 1970. This is how we denoise the image, because suppose we will see it using the examples we have, and you will get the better intuition. So for the Gaussian blurring, we have this function. We have to give input image. We have to specify the kernel size. We have to specify the standard deviation also. But if you will specify 0, then it will automatically calculate it using the kernel size. So moving forward, this is how we can apply a Gaussian blurring. I use a 3x3 filter. So this is the input image. This is the Gaussian. This is how a Gaussian blurring looks like. And this is a Gaussian blurring looks like if you use a kernel of 5x5. We will see their advantages also, how they reduce the noise also. So don't worry about it. So this is the real image, guys. Okay. So suppose I added some real image. I added some Gaussian noise in it. So this is how a Gaussian noise looks like. So after applying it through a Gaussian blurring, you will get this result. Although you can see these both results are not same. Here you can observe some noise as well, but it is far better than this if you compare both of these. So that's why we use the Gaussian blurring. Resizing, that's the point. Resizing of an image added some Gaussian noise in it. That's why we use Gaussian blurring in the processing stage. That's a very important point of an asked in an interview also. So now we have another blurring method, median blurring. Guys, understand median blurring is a non-linear digital filtering techniques, while the Gaussian and the simple is a linear. Here we are going to use a non-linear filter, and this is highly effective. The median blur is highly effective to reduce the salt and pepper noise. We will see what the salt and pepper noise. So this is same how we can implement the median blurring. We will specify median blur via function. We will specify the image and we will give the kernel size. Here we only specified the single value. Here we have to give the dimension 3 into 3. So that's the difference. So this is the image with a salt and paper noise. So if you apply a Gaussian blurring, this is how a result look like. Here you can see the kernel size is 3 by 3. And if you apply a median blurring, this is how the image looks like. Here you can see the noise which we have in our previous in our source image. It is completely removed from the image using the median blur. So that's why we use it using. That's why we use median blur if we have a salt and pepper noise. So now I hope the one guy who asked why we have to blur our image before denoising. It's not blurring. It's basically we are denoising the image using the blurring method. Okay. Okay. Comparison between the median and Gaussian blurring method. So I will change the slide, guys. We have a good comparison. Can you see the window, guys? Type yes if you can see the image, the Chrome window. Okay, cool. So here this is a Gaussian noise and this is a salt and pepper noise in an image. We apply a mean filter here, average filter. By mean filter we mean the average filter. Let me zoom it. So this is how you get. And if you apply a Gaussian filter, this is the result you will get. And if you apply the median filter, this is the result you will get. So in terms of Gaussian noise, here you can observe that Gaussian filter works better as compared to median and as compared to mean. And in case of salt and pepper noise, the median filtering works better. Okay. Okay, so that is all about that thing. And this is important. In Gaussian noise, a normally distributed random value is added to each pixels, guys. And on the other hand, salt and pepper noise describe a situation where random pixel get replaced by extremely dark or bright values. So that's the difference between a Gaussian noise and the salt and pepper noise. Here, the noise in present in each and every pixels, but here the noise is not present in each and every pixel, but there are some random value we put on random pixels we put on the image. So we will move to our slide. So this is all about Gaussian blurring. Now we have Gaussian blurring and median blurring. Now we have one of the most important filter, bilateral filter. It is also non-linear, but the advantage of using it is it preserves the edge in an image. It reduces the noise, but it preserves the high frequency edge. So how you can apply it using this simple function, bilateral filter, and you need to give the input image, diameter, sigma color, sigma space, and border type. Okay. So this is how you can implement it. Bilateral blur, ing. You give the image, and here you give the diameter which you are going to use, and the sigma color and sigma spaces. So generally we use 75 into 75 for sigma value, and we can increase and decrease if you wanted to get more blurring. So this is our input image, and this is how a bilateral image looks like after applying a bilateral filtering. Here you can see the images. Here you can observe the images as well. In this image, it is not clear. We will see an example in our later stages where you can see we will use a bilateral filter to preserve the edges and array and to blur the background. Okay. Now, do you guys have any doubt on blurring? Because we are moving forward to an edge detection. Type yes and no. Yeah. Okay. So edge detection is basically, so whenever you are working on an object detection algorithm, face detection algorithm, so you need to focus, you need to extract the edge from the image, right? So how will you do that? So that's the, so we have a very famous technique, algorithm in our OpenCV, which is called as a canny edge detection. It is one of the popular edge detection algorithm available in OpenCV. It works with the stages. First, we reduces the noise. Second, we calculated the intensity gradient of the image. Third, we use a non-max suppression, and fourth, we will use a hysteresis thresholding. So what is basically do? So noise reduction, we use the Gaussian blurring, and then the noise reduction is basically, this image is then processed with a Sobel filter. Guys, remember this term. This is often asked in an interview. What is Sobel filter? So Sobel filter is basically a filter uh, which is used to detect an edge on an image. So how it will do it? It is basically based on the gradient of each pixel. So we calculated the gradient, and as per the gradients, we get the edges. So the Sobel, okay. Now we will move to a non-max suppression. Non-max suppression is used to suppress the unwanted pixel which do not have contribution to edges. This is very clear from the um, definition. And now we have a hysteresis thresholding. In this stage, we will classify which are our edge, which are our non-edge by giving the threshold. Okay. So we will see. This is the function. Kenny, we have. And there are 4 parameters. You need to give the input image. You need sigma to determine the amount of Gaussian smoothing you want. First, you will give minimum thresholding and maximum thresholding. The higher the threshold, the cleaner are the edges. Okay, that's the point to remember. So this is how you can implement it. Basically, a one line code, cv.kenny. This Kenny will implement all the 4 things in a single shot for you. So this is the image, and this is how an image looks like after a canny edge detection. We use a lower threshold of 100 and 200. If we increase the threshold, here you can see we are, if we increase the threshold, then we are easily get rid of these lower frequency edges, and it can more focus on our foreground. But it is not good, guys. You can see after applying a edge detection, Kenny, the best algorithm we have in our OpenCV, but after this, the image is not looking good because there's a lot of background edges. We don't want this in our image. So what we will do? We will try to improve our Kenny edge detection. So what we will use? We will use bilateral filtering. I already specified you guys that bilateral filtering is used when you want to reduces the noise, the background noise, and you wanted to preserve the edge in an image. So this is, we apply a bilateral filter, and then we will apply a Kenny. So this is the input image, and this is the Kenny edge detection after bilateral filtering. You can see here we reduces the background noise by a lot. Simarjeet Kaur, do you have any doubt? Okay, Simarjeet, please do not annotate on the screen because it is bothering me. Okay. Okay, so this is the canny edge detection without the bilateral filtering. Here you can see this looks far better than this. Okay, so this is the effectiveness of the bilateral filtering. Now moving forward, we have a contour detection in OpenCV. Contour is simply a curve joining all the continuous point having same color or intensity. The contour are useful tool for shape analysis and object detection and recognition. So that's the important point here. And the second most important point is the contour detection is applied after the canny edge filter. So we will use a fine contour method to find the contours and draw contours method to draw the contour. So basically we get the image, we apply a Gaussian blurring. As I say, we used it in our pre-processing stage. After this, we will apply a canny. Although canny also apply a Gaussian blurring in its algorithm part, but you can leave this thing if you don't want to use it. And then you find the contours. You specify the input image. You have to specify the contour interval method and the contour approximation method. So basically, you can refer for all these two parameters in a documentation part, guys. So, and this way, this is the image. You apply a canny edge filter, and here you can plot the contours. This is how contours look like. Contour basically help us to localize the shapes in the image. Here you can see it help us to localize the window. Here you can see we are okay. Wait a second, guys. So we have a application of the contour, convex hull, image foreground extraction, fitting the curve in an image, bounding box drawing, the one you see in the OpenCV. You can use contour detection to bound the box, and many more things. Many applications are there. So basically, now we will. You can guys you do check about the convex hull. It is one of the concept in which you try to bound the box around an object which looks which is convex. So that is the thing. We will not cover it here. Okay, now we will have a quick questions. What the use of Sobel operation in an OpenCV, guys? Okay. First, to detect the image. Okay. Okay, 1. 3, to blur the image. Okay. Sarath Haver. Okay, the answer is 1. To detect the edges. I already told you to remember this Sobel. We use a Sobel filter, which is basically help us to determine the edges of the image using the gradients. Okay, so it is not used for blurring method, I guess. Are you clear, Sarath? Yes. Okay. Now the second question is, which is the edge preserving blurring method? That is often asked in our interview also. We have 4 options: Gaussian blurring, bilateral blurring, average blurring, median blurring. Okay. Percursing side to Synergy to Sersha. Okay. You guys got it. So correct answer is bilateral filtering. So among now moving to a third question. Among the following, which are the non-linear filtering techniques? Okay, 4. Median blurring. 2. Okay. There can be a multiple answers also, guys, in this one. I haven't seen any correct answer yet. 2 and 4. Yes, Anusa, you got it. So the correct answer is 2 and 4. The Gaussian blurring and average blurring is a linear filtering techniques, while in bilateral and medial blurring, we are going to use a non-linear filter. Okay. Moving forward, now this is almost the end of the PPT. We are left with two more concepts. So bitwise operation, guys. So in your 10th and 12th, you have studied about the AND or NOT OR operation. You know what these operations do, and basically take the intersection, or basically takes the union, not basically convert the basically use for a conversion 1 2 0 0 to 1, and similarly we use JOR, intersection over union. So this operation can also be performed in an image. And what the need of bitwise operation, guys? They will help you to extract the region of the interest. Basically, they use in a masking technique. We will see how. So moving. So this is a circle, and this is the rectangle. We perform the AND operation. It basically take the intersection of it. We perform the OR operation. It takes the union. We perform the JOR, and we perform the NOT operation as well. So this is how the image looks. So we will see the application of the bitwise, how we can do the masking after morphological operations. So now this is the last portion which we have, morphological operation, and the collection of non-linear operation related to a shape or morphology of feature in an image is known as morphological processing. So basically, so what morphological operation help us to do? We will see it through the examples, I guess. It will be more clear to you guys. So morphological operations rely on a relative ordering of the pixel value, not on their numerical value. And the important thing is it is normally performed on a binary image. So how we are going to convert the image to a binary image? So that's why we need to apply a thresholding. Thresholding basically convert the image into a binary format. By binary, I mean we only have two values, 0 and the maximum 255. Okay. So we have these types of morphological operations: erosion, dilation, closing, opening, gradient. We will see erosion. We will see each of these operations. First is erosion. In erosion, it basically erode away the boundary of the foreground object. So in erosion, what we do basically, we have a kernel. We will slide it. We have a kernel. We will slide it over here. So if all the pixels under the kernel is 1, then we will make it 1. Otherwise, it will consider it as 0. So what's the use of it? It will help us to reduce the thickness of the white region in an image. Okay. Erosion can be helpful for removing all the white noise. We will see how. So this is the function cv.erode, which basically help us to erode the image. So input image, first parameter, second parameter is kernel, the dimension of the kernel. Okay. So this is the input image. So in this image, you can see there's a small noises here, and I don't want in my image. So I want these things to be removed. So what I can do, I can use the erosion technique. So what will erosion technique does? It will have a filter. The filter has a value 1. All the value of the filter will be 1. Okay. So then you will perform the element wise multiplication. If the multiplication is 1, then you will only consider it as a 1. So by 1, I mean the brightest pixel. Since we are working on a binary image, we only have two things, 0 and 1. 1 is corresponding to a white and 0 is corresponding to black. So here, if you apply a filter here you can see there's a lot of black thing and a white thing is also there. So it basically erode this thing. So here you can see this is how we get these small white noises denoised in this image. So we increase the kernel size and increase the iteration, we will get the better image. But the thing is, it also reduces the width of the thickness of the white region, because suppose if you are working in this region, okay, so here you can see there's some white portion which will also automatically get 0. So that is why it reduces the thickness of the white region. Okay. Now delation is just of opposite of the erosion. It basically increases the white region. Suppose I have this circle. Okay. Okay, I have this circle, but it is not clearly visible to me. You can see there's some of intensity related issue, right? It is not clear. Suppose you have a black noise like these here, you wanted to emphasize more on it, so you can use a dilation. So it's just same as erosion, but it's just opposite of it. So the function which we will use is dilate, and we will dilate the image. The kernel will be same, but the thing is, if all the pixel value under the kernel is 1, then it is considered as 0, otherwise it is considered as 1. So that's the same thing. So we have opening. Opening is erosion followed by dilation. So in erosion, what we do, we basically reduces the white noise, and in dilation, what we will do, we increases the white noise. So suppose this is an image, okay, but I wanted to remove this noise here, but I apply erosion, okay, and my noise is gone. Now I am happy. But on the other hand, you can see the thickness of the white region also reduces. Here you can see the thickness of the white region in this case, and in this case, it is reduces. Now I want the same thickness. What I will do, I will use dilation after using the erosion. So once I remove my noise, then I will dilate my image so that I can have so that I can increase the thickness. So here you can see, this is how we do. First we erode the image and then we dilate it. So we do not perform these operations one by one. So in OpenCV, we have a simple function opening that will make sure that first it erodes the image and it will dilate the image. And we have closing also. Closing is just opposite of the erosion. So just like it reduces the, so okay, I will go here, dilation. So just like the erosion reduces the white region, the dilation increases the black region. It removes the black region. Suppose here the black region, and you just increase the thickness. So this is how you decrease the black region. So now see, okay, now we will take a case study here. This is the original image, okay. Now I apply threshold. So this is how an image looks like. But as I mentioned earlier in my slide, that the result is not good after applying the threshold thing. So we need to further improve it. Okay. So can you guys can tell me how I can fill this black noise using I mean, which operation will help me to reduce this black noise? Okay. Okay, I will go on because we have very less time. Okay. We need to cover the applications also. Yes. So what we will do, first we will apply the dilation, because it will the dilation will reduces the black noise here. But after the dilation, you will see the thickness of this white region also decreases. So you need to increase it. So that's why you need to erode it. You need to perform the erosion. So that's why we will perform the closing here. So closing is just first we dilate the image, then we will erode. We will do the erosion. Okay. Okay, I can see Sarath, you write erosion. Erosion help us to remove the white noise. Okay. And dilation help us to remove the black noise. So here we have a black noise, we need to do it white. So we apply a closing, which is basically dilation. Then we will apply an erosion. So I will. So this is how we segment the image. Basically, we have this image. we got this mask after applying the threshold. Then we will perform an AND operation. I said that it is the bitwise operation help us in a masking purpose. So if you will perform an AND operation, then the background will be converted to a 0 and you will get this intersection here, the intersection of the face. So here you will see the black noise is also there, but after performing a closing, you will get this type of result. If you perform a closing here, so you will get this type of operation, and then you can take an AND operation, and this is where you segment the picture. Okay, now cool. We have another morphological gradient. It's a difference between the dilation and the erosion. It basically gives you one more outline to our object. Here you can see. So this is the way we implement it. Okay, this is how we can also draw a rectangle. And this is the way I draw a circle. This is the bitwise operation. Okay. Okay, I forgot to include the the implementation part of the morphological gradient. My bad, but we will. Okay, that is the bitwise operations. Okay, you can check the collab file after that. Okay, now moving forward to a question. This is the end of the slide, I guess. Okay, so morphological operation can be performed on RGB image, VGR image, grayscale image, binary image. Comment down fast, guys. I'm seeing the chat box. So question is, morphological operation can be performed on, sir, yes, we are going to cover it. Don't take action. We are going to cover 2 projects, not 1. Okay. Okay, the correct answer is binary. Yes, grayscale image also right, but in grayscale we have image from 0 to 255. So we need to convert it to a binary. That's why we will apply a thresholding in a grayscale image and we will get it to convert it into a binary image. Yes, Sarabjit, you are right. We will perform the morphological operations on a binary image. So now, which operation you will perform when you need to fill the black noise in a binary image? So I've talked about it. Yeah. Yes. Okay, Anusa, D. Yes, it is D. D is the correct answer. Dilation followed by erosion. And also, closing is same as dilation followed by erosion. It's just the different name. Okay. So answer will be B and D. Okay, guys. Do anyone have any doubt? Okay. Anushka said okay. So this is all about the theoretical portion. Now you guys are well versed with what is OpenCV, what are the various functions we have, and now we will see some of the applications of the OpenCV. Okay. So give me a second. Meanwhile, if you have any doubt, please drop it in the chat box. Do we have any doubt? Yes and no. Okay. Can you see? Thank you so much for such an informative session. Looking for more. No doubts. Okay. Now we are going to cover the implementation part. Okay. So first we will go OpenCV lane detection. So this is the road. Okay. And we wanted to segment out the lanes from here because it is one of the feature we have in a self-driving car. So this is how we are going to segment it. So we will see how we performed it using the OpenCV. Okay. Are you? Is my screen visible to you guys? Yes or no? Yes. Yes, yes. Okay. Now it's much better, I guess. Can you see the Jupyter notebook clearly? Yes, okay. So yes, yes. Okay, okay, okay. So first we will import the libraries which we are going to use. We imported the OpenCV library. How we import it? This is the import function which help us to do this task. So import CV2. Basically, this you have to specify CV2 in order to import OpenCV. Okay. I imported the NumPy also as NP, and I have imported the matplotlib also. Okay, for plotting for showing this image. Although I can use the OpenCV functions IMSO also, but in OpenCV, if you use the IMSO function, you will get a different window. A different window will pop up. Whereas if you use the matplotlib, it will be in your Jupyter notebook, so you will not get any other window. So that's why I use. You can use the IMSO of the OpenCV as well. So first I specified the path of the image which I am looking for, in which I will going to segment out the lanes. Okay, so this is the path, and this is the cv2.imread and I specified the path. This is how I read the image. Okay. Okay, so now moving forward, I have converted this VGR image to an RGB image because, guys, I already told you matplotlib read the image in a RGB format. The IMSO function will read it in a RGB format. So if you give a VGR format to a plt.imso function, then it will give you some different image conditions. So first I convert it to an RGB format. So this is the image in which we are working. Here you can see the dimension of the image. We can see the dimension using img.shape. So here it will give you the dimension. This is number of rows. Rows means you have height. This is height. This is width, and this is number of channel. This is an RGB image. We have a 3 channel. Okay. Now this is very big image. I want to resize it because I don't because I wanted to have some efficiency in terms of time complexity. So I resize it into a 400 into a 400. So this is how our image look like after we resize it into a 400 into 400. Okay. Now you wanted to segment these lanes in a road. So what you can use, I already talked about it, the segmentation method. So what you will use, thresholding. You will apply a thresholding in order to segment the pixels in your image. So for the thresholding part, you need to convert the image into a grayscale. So this is I have converted the same image using CVT color method to. Okay, we can see we have a doubt. Will you share this code? Okay, yes, we will share it. Don't worry about it. Okay. Focus on the implementation part. Okay. So CVT color, and this is how we converted this image into a grayscale. So this is the grayscale image looks like. PPT as well, sir. Okay, guys, please focus on the implementation part. We will share everything. It's open source toward machine learning. Okay. Functions to load the image. So I have incorporated all these things in a single function so that it will be a handy for us. So I define a function load image in which I read the image, I resize it, and I convert into a RGB format. And apart from this, I use a Gaussian blurring here because I already mentioned you that resizing increase a Gaussian resizing introduce a Gaussian blurring in the Gaussian noise in an image. So in order to denoise the image, we will have to use the Gaussian blurring. So here I use a Gaussian blur. I give the image. The kernel is 3x3, which I'm going to use. So this is how our image looks like. Okay. This is the grayscale image. Okay. Now thresholding only works if we have a high contrast image. If you have a high contrast, then thresholding will work better. So we need to increase, we need to add some contrast in an image. How we can do it? We have a function, convert scale AVS. This function help us to add the contrast in an image. So this is the basic, what you can say, mathematical explanation behind it. This is the matrix. You can think of it as a matrix, and this is a F matrix. The alpha beta parameters is basically used for contrast control and brightness control. Alpha controls the contrast, beta controls the brightness. So here I specified alpha is 1.5 and gives the grayscale image, and beta is 0 because I do not want to increase the brightness, because I think it's clear. I need to increase the contrast, so because it looks a little darker. Okay, so this is how the increased contrast image look like. Okay, now we will apply a threshold here because we need to segment this white pixels from the dark one. So in segmentation purpose, what I use the 235 as the thresholding, because guys, you know that that a white pixel corresponding to a 255. If you have a 255, then it is known as a white pixel. It will be a brightest white pixel. So I only want to bother about the white lane here. So I will use a threshold of 255. So this is how the image looks after thresholding. Now you can see you have the lane, but you have some other things also. You have this thing, you have this thing also, and yeah, you can see the image is the lane is not, what you can say, is not continuous. We have some black impurities noise here. So then okay, we can edge detect after this to get the edges so that we can plot the contour. Okay, so this is how we perform a edge detection. After the edge detection, we are going to dilate the edge, because here you can see we have a black impurities. We want a continuous contour in order to plot. So we specify a kernel. I already specified you the kernel will be a kernel of ones, and this is how we dilate the image. So this is how the result look like after dilating. Okay, now we find a contour. So the thing here is, here you can see we get, okay, we will see after applying a fine contour, we will get a list which have all the contours in the image. So what can be a possible contours? This can be one of the possible contours. Okay, and this can be a 1, this can be a second, this can be a third, fourth, fifth, sixth, seventh, and this can be a 1 contour as well. This can be a 1 contour as well. This can be a 1 contour as well. So we will get a list after this. So what I have done is I have sorted that list and I have plotted the biggest contour, which you can see here. So if you plot, so this is how the image looks like. Okay, so this is how we segment the lanes. The thing is, this is just a very basic image segmentation lane detection I have implemented using the OpenCV. We have furthermore advanced techniques also. We can use what we can do. We can crop the region from the image. Okay, so you get the desired region of the interest, and then you will apply all these filters there. Okay, and we will have another method also, Hug transform. So that will help us in many things. We do not have to find the contours and sorting, all those things. It will do it for ourselves. Okay, now moving back to some advanced lane detection. So in advanced lane detection, what we can use a CNN classifier so that we can increase our accuracy. So basically in industry level, we use the CNN classifiers and other things. So this is just for the practice, all the things which I have said, because I have covered all the functions which I have taught you. Okay, let's look some of the more optimization. We can do a little optimization here. So this is the complete function. I have converted into a simple function, and these are all the operations we have. So let's see, this is an image. This is how we segment the lanes. Now we have another image, and this is how we segment it. But you can see we have a lot of noise here. This is not at all good. If you are using an self-driving car, it will get crashed. Okay, so we need to further improve it. Okay, so for the improvement purpose, what I have done is I have just changed the kernel either. In my previous case, I am using the kernel which is of ones matrix, but here I am using this kernel. So this kernel will help us to focus more on the what you can say edge thing, because I told you about the working object deletion. So, and help us to get the longest contour. Okay, and apart from this, I also use a Sobel filter here before a canny edge detection. So this Sobel filter is also an edge detection filter, I told you, but in Sobel filter we do not get all the better result. We just get temporary type of result, and after that we use a canny edge detection over the same Sobel filter. So in order to get rid of the small edges where it is. Okay, this small edges. So if we use a Sobel filter, then these will not be considered, because it will only consider the brightest high frequency edges. Okay, that is more predominant, and then we will use the canny on those predominant edges. So this is the result after doing some two optimization in a simple function. And this is our previous case, and this is how it goes. So that is all about the lane detection, guys. The second thing also have so many of the downfalls if you are going to use if you are going to take furthermore different examples. So we need to use a deep learning algorithm or CNN architecture in order to train the lane detection, and this is just a basic, but and if you will do the deep learning, if you will create that thing also, the classifier, deep learning classifier, then you also need all those functions to work, because if you're not aware of these functions, you can't build a classifier, because building a classifier is a second task. First is the pre-processing stage. So in pre-processing stage, you need to convert it to a grayscale. You need to do the image enhancement also. You will apply a threshold also. Then you will train your CNN architecture and many more things. Okay. High order attendance. Okay. Now we will quickly cover the face detection in an OpenCV. It will take hardly 10 minutes. Okay. Is the Word doc visible to you guys? Type yes and no.
Yes, sir.
Okay. That's better. Voice is better. So face detection is a technique that identifies or locate human face in an image. So this is how we locate it. We are not bothered about the whom the face belongs to, but here we only bother about how can we make a machine to learn the face. So for face detection is performed by a classifier. Okay. So okay, I can see we have some. Yes. Okay. So the classifier returns the probability whether the face is present or not. So first we need to train the classifier on 1,000 of the image and with and without faces in order to work accurately. But here we are not going to do any type of training. We are just using the OpenCV pre-trained classifier. So in OpenCV, guys, we have two pre-trained classifier, Haar classifier and local binary patterns, LPP classifier. So in this thing, we are only going to discuss about the Haar classifier. Okay. So although Haar classifier are more sensitive to noise as compared to LBP classifier or other deep learning algorithm, but just like you have YOLO, you have RetinaNet, these are far better, and we have MTCNN, that is the state of the art technique in order to detect the face. So, but here we are only focusing on the OpenCV Haar based classifier. So, what are some advantages why we are using it? So, first thing is they are lightweight. Second is they are super fast. Even on a resource constrained device, we can use it. Suppose your model cannot implement so much of computational, if it doesn't have so much of computational efficiency, it can't perform so much of the computation, you cannot deploy the deep learning model on that app, and there can be many things. Your mobile doesn't support that much of the computation. So here you use the Haar Cascade model. It is very tiny and it can perform on any device that can run C. Okay, so we will cover the basic overview. We are not going to cover the full algorithm here because we are running out of the time. Okay, so Haar feature based classifier. So basically it extracted the Haar feature. How it will extract the Haar features? Here you can see. We have these type of, wait a second. So we have these type of filters through which we detected the Haar features. So these are for the edge detection. These are used for line detection. For rectangle, you can be used for any of other feature detection algorithm. So the algorithm is basically distributed into 4 types. First, we need to extract the Haar features in an image. How we are going to do that? We will put the edge filter here, and we will calculate the value under this under the black strip and under the white strip, and we will take the difference. So the difference will give you the changes of the intensity and the changes of the intensity, and that's how you will extract the Haar feature. And now we have another concept, integral image concept. So basically what integral image concept is done it will reduce this calculation, because we need to perform the multiplication in this strip and in this strip also, and then we have to subtract it in order to extract the Haar feature. So what integral image concept do? It basically help us to reduce this computation. You can check out the research paper as well. Here you can see a complete explanation. It is all about the mathematics and the pattern we observe. Okay, now next is add a boost technique, which we apply in this algorithm. So it increases the classifier accuracy, because it only select only those features which are belong to a face. Okay, now we have a cascade classifier here. So we have an image. We will extract the Haar features, and we will check whether this feature is belong to face or not. So what we can do, we can group all these features in a single in different subsets. Here you can see. So if this is if you are working with this and you extracted this feature and you check using the classifier whether it has the feature which we are going to focus on or not, then if yes, then it will be 1, and 0 otherwise. Okay, you can check the proper working there, guys, because in a documentation part. Okay, now moving back to implementation part. So implementation is very easy. Okay, so first you have to read the image. I read the image, and this is Elon Musk, and so I showed the image. I convert this image to a grayscale in order to get the efficiency, in order to increase the efficiency, because I can also use the RGB scale also, but I will use a grayscale as I already told you about it. The advantages of using the grayscale, the time complexity. So this is how I convert it. This is the image. Now I load the classifier, that is the different that's the thing, and face detection. So you can visit the GitHub repository of the OpenCV, where they have a lot of pre-trained classifier. So here you can find a file, har cascade underscore frontal underscore face underscore default dot xml file. So all these classifier are available in the form of XML classifier. So you can download it, and then you can specify under the cv.cascade classifier, and you can specify the path here. And so they are pre-trained classifier, obviously. So we have many more other classifier also for eyes, for ears as well, for smile detection also. Here we are mainly focusing on face detection method. So after this, you will detect the feature, this har underscore cascade underscore detect multi-scale. Okay, you will give the grayscale image. There are few parameters, we will talk about it: scale factor, minimum neighbors, and minimum size. Okay, so this the function help us to detect the face. So it has a parameter. First parameter is scale factor. So basically in an image, some image can be very near. If you are capturing a photo of a group, then some people can be very near to the camera, and some can be very far. So this is how an image pyramid looks like. So first we will take the bigger image, then we will for the face detection only, we will scale it down, and then we will extract the har feature, and then we will again scale it down and perform the har feature, and we will again scale it down, perform the har feature extraction. So in this way we can detect the faces which are nearby to the camera as well, and which are very greater distance to the camera. The second is minimum neighbor. The cascade classifier will detect multiple windows around the face. Okay, so let's say if you are working here, so your cascade classifier detect the face here. So obviously the face can be here also. So it can be an overlapping type of situation. So that's why you use the minimum neighbor, in which you specified how many of the face can be more detected in a neighborhood. Okay, and then the minimum size, which basically the bounding box. All the small bounding boxes are ignored, because we can have a bounding box here because it's a part of the image. We can have a bounding box here because it's a part of the image. We can have a greater bounding box. So we will perform the ADA boost here, and because of the ADA boost, we will get the face. Okay, we will get this type of bounding box, only a single bounding box. So this is how, after this, you have to draw a rectangle. You will get the coordinate by this face underscore rectangle. You will get the coordinate of your face, and then you will print a rectangle around it. You can also use a circle for that case. So this is all about the face detection. So we have many cascade available in our repository. So you guys go and implement yourself. That is very easy. Okay, and furthermore, we can also use a real-time detection using your webcam, because reading a video is same as reading an image. In video we have different we have many frames in which we are working, which are running. So we can we have a function in our OpenCV to read the video frames. Okay, I can see there's one option of chat. Sir, code. That is the okay. Wait a second. So this is the basic code we have, guys. This is the only code, a 10-minute code, a 5-minute code for detecting a face. But you should know how a cascade classifier works. Okay, so this is how we import it. So this is the wait a second, guys. So this is the function, we will run it, and this is the image in which we are going to work. Okay, so we have here 1, 2, 3, 4, 5 faces. Let's see how our algorithm works. So first we convert it to a grayscale. Okay, and let's see how a grayscale image looks like. So this is how a grayscale image looks like. Then we will get the Cascade Classifier. This is a path where I stored my Cascade Classifier. I downloaded it using the GitHub repository of OpenCV, and then I implemented a detect multi-scale function that will help us to detect the faces. I use the scale factor of 1.1, so every time it will reduce the frame size by 10%, and the minimum neighbor is 1, and minimum bounding box size is 30. Okay, so I implemented it. You can also see the length. It will return you the tuples with the coordinate of the face, so you can count that tuples. So here you can see we get 7 faces, guys. So here you can see this is classified as face, this is also classified as face, this is also classified, but this is also classified as face, and here you can see this is also classified as face. So that is the thing, guys, because in an OpenCV based hard classifier, very tiny, and they don't have any advanced technique. They are built before that, before the deep learning ever exists. So these are the first classical algorithm, and it can prone to a noise, but it has its advantages also, that it can run on a device which have low computational power. And many things I already told you, they are tiny in size. So that is all about the session, guys. I'm stopping the sharing. If you have any doubt, please feel free to ask. Okay, do we have any doubt?
Guys, would request all of you to participate. If you guys have any doubt, put that into comment section. If you guys do not have any doubt, paste no in the comment section, so we can take it further and wrap the whole live session. Okay, no doubts.
Okay, and one more thing, I know I have gone fast on the. Are there any DNN based? Yeah, we will have a next session on a face detection, object detection algorithm, and we will cover there. Okay, and one more thing, I would like to share that I go very fast on a code, but it is very easy. I have taken you all the functions in an OpenCV, and if you will see it again, then you will find it very easy. So practice, guys, because practice makes you perfect. And that's all from my side.
Yeah, as Ansh said, practice makes perfect. So do practice after the live session. And thank you so much, Ansh, for such an informative and amazing live session on the OpenCV. Computer vision applications market is growing in the data science. So I'm sure this live session would have helped all the data science enthusiasts. And now, since we are about to close the session, and feedback becomes very important to understand what we are doing right and where we can improve, whether this initiative is helping the end data science practitioners or not. So I'll open up the form to have a quick feedback, discussion for all participants. So could you guys, comment down your thoughts? What do you think? Like this live session is helping you guys? Did we deliver the knowledge that you were looking for? Any comment, thought on the content or the whole live session? Anything? Do we have the quick feedback from every one of you? Yes, we'll share the PPT notes, everything. Do not worry about it. The whole content is for you guys. So this will be shared on our website, that is towardsmachinelearning.org. We are on all social media platforms like LinkedIn, Facebook, Instagram. So do check on those platforms as well. We Ansha has posted the website link. Okay, we see the feedback coming in, and do you guys know that we have posted the poll regarding timings of the live session? Just to get the one common time that works out best for all. It will ensure that everybody is able to attend the live session. So it should not happen that people are having their dinner, or live session is coming in the dinner time, or is maybe may not be at the right time. So could you guys comment down on are you guys aware of the poll that we have opened up on our LinkedIn page? Yes, no? No? Okay, Sanat Lakshmi says no. Okay, I see Sanat Lakshmi has been very active on our Instagram channel. I see you are not keeping up to date with the LinkedIn page. So I'll paste down the link. Okay, so do mark what do you think? Okay, open up the link and tell me in the comment section what in all options do you see in the poll options. So I'll be sure, okay, you guys are able to access that particular post. The whole post is all about taking your opinion of what times work out best for you guys. Let me know in the comment section if you guys are able to open the link that I have just pasted in the chat window. You can mention what do you see in the poll options, and I'll be knowing, okay, you are referring to the right post. Meanwhile, I saw one professor joining the session. If I'm not wrong, it was Ssb Singh. So could you, sir, please unmute yourself and talk a few words about the session, maybe your overall feedback. What do you think about the live session that you attended today? Do we still have Sarbjit?
Hello.
Yeah, hi Sarbjit. Hi sir. How are you guys? How are you doing?
Great, sir. It was very informative session,
Mm-hmm.
and it was very helpful and in very simple language. It was new to me, but it was because of simple language, it was more understandable and interactive session as compared to other session available on social media platforms like YouTube, data science or machine learning.
Yes. Okay. Okay. Would you mind telling me the college name, sir? Like which college you are professor into?
DAV College for Women, Firozpur, Kant, in Punjab.
DAV College, Punjab. Okay. I'm sure that you will be able to cascade the same words to your students as well in your college. The people or the students who are enthusiastic about the data science journey. We are conducting a live session every weekend. That is free of cost. There is no single penny charged. We are sharing the daily content on the ML and AI on our Instagram channel, on our Facebook channel as well. So you can ask students to attend these live sessions. We are even providing the participation certificate as well that will help them shape their CVs for their future interviews also.
Yes, sir, definitely.
Okay, thank you so much, sir. It was great to have you in the session today.
Thanks, sir.
Yeah, thank you so much.
Thanks for the session.
Yeah, thank you so much. You guys, it's you guys who make the session successful. By making it interactive, I could see the whole live session today was so interactive. Everybody was participating in the in this live session. So it was good. It was good. I personally enjoyed the live session. And we follow a practice here. We do not collect the feedback through some Google form. Instead, we ask our participants to share their feedback on a LinkedIn page. So
it'll help us achieve two things. One is we'll have the good interaction on our LinkedIn page, and that will help us apply for the LinkedIn Live. So we'll take off this registration process for the live session. We'll directly go live on the LinkedIn, because our major audience, most of the students who wants to pursue their career in data science, are on the LinkedIn, and the people who have experience into data science already, they are also on the LinkedIn. So we want to make sure that we reduce one extra step, that is registration part, to attend the live session. So second is, it will help others also to know how the live session went. So when you share your feedback on a LinkedIn page, so it will, if that particular post come across somebody, then they get to know, okay, how the live session went, whether it was informative, whether it was it was something that went wrong, should they attend the live session or not. So I'll request you guys to share your feedback on the LinkedIn page. I'm sharing the LinkedIn page link right away in the chat window. You should see the poster for today's live session. Yes, hi Nivedya. I have just pasted the LinkedIn page link in the chat window. Okay, so you need to provide the feedback on the poster that is of today's live session. Okay, so share your feedback in the comment section. Whatever is it, positive, negative, we are not going to delete if there is any negative feedback coming in. In fact, that will help us improve where we are lacking. Do you all follow that? Could you guys paste in the chat window yes if you guys follow that, what I'm saying? Okay, Gavi says yes. Vivo 1917. I would have appreciated if I could know your name, Vivo 1917. Okay, so I'll also share the attendance link. Mark your attendance. So we will be able to release the participation certificate as well. And here is a catch, guys. Okay, so the people who are sharing their feedback on the LinkedIn page would be given the participation certificate. Does that make sense? Do all of you agree upon sharing the feedback on the LinkedIn page? Okay, we have response coming in. Can we have response from other participants as well? Okay, we have more responses coming in. Yeah, so do share your feedback on the LinkedIn page. That will help us in many ways. It will help us to reach the end data science practitioners and take this initiative to the more people. Okay, already did, sir. Thank you so much, Sharad. Okay, any question before we wrap up today's call to me or to the Ansh, or anything about the session, anything about the content maybe? We'll be sharing the content code, everything on our website. So do keep check on the website as well. Whenever the content is out, we'll be putting the post on the LinkedIn page as well, saying that we have released the content on this topic today. So do not worry about it. The whole recording will also be shared on the LinkedIn page, on our Instagram page as well. So if you guys are not aware of the Instagram, Facebook page, I'll share that as well. So bookmark the pages. Make sure that you guys are following the pages to make sure that you do not miss out on any content and on the recording of the live session as well. Okay. So if you guys do not have any question, say no in the chat window. If you guys have any question, unmute yourself, speak to the Ansh or me, whosoever your doubt is connected with. Can we have the responses coming in? Okay, no question from Sanat Lakshmi. Thank you so much, Sanat Lakshmi. You've been great. You've been attending all the live sessions, I believe, and you've been very active on the Instagram as well. Do we have response from others as well, or are we good to wind up the call? Okay. Okay, then I guess we can wind up the call for today. Thank you so much, guys, for attending the live session today. We have Sandeep saying in session was very informative. Thank you so much, Sandeep. Thank you, Chanda. Bye bye, guys. Take care. Good night. Happy weekend.